the product rule for differentiation. These two functions are multiplied. We have the product of two functions of x, and again in this example, and again in this example. So we'll write this as y is equal to u of x times v of x, the product of two functions of x, which we can simplify to just y is equal to u times v. This is the actual formula for the product rule for differentiation, this formula here. But in most cases you don't need to write this formula down before you can apply it. There's actually quite a simple way of doing so. So you write down one of your functions of x here, function u, and the other function of x here. So we differentiate this function du by dx, we differentiate this function dv by dx, and then you can see from our formula here v times du by dx, so we're cross multiplying these two, u times dv by dx, we're cross multiplying these two, and then you add those results together and you're done. So y is equal to x squared sine x, so write x squared sine x, differentiate each one, so 2x, so differentiate sine, we've got cos x, and then we're going to cross multiply, and the order in which you do this doesn't really matter. You can multiply these two first or these two first. So if I multiply these two, I've got 2x sine x plus, and then this way x squared cos x, and that's all there is to it. Example 1, so function u, function v, so put each function separately, differentiate each one, and then applying the formula, and the formula is unnecessary to follow at this stage. So all we're doing is cross multiplying this way, so 2x times e to the power 4x, like this, plus, then cross multiplying this way, so we've got 4x squared e to the 4x. There we go. Example 2, again we set up the problem the same way. So 1 over x is x to the power of minus 1, and then we've got sine 2x, differentiating each, and we're using function notation, so cross multiplying, plus, and then multiplying this way. Example 3, our two functions of x using index form here, so differentiate each, and simplifying this. And just in case you didn't pick up on this, when you differentiate 3x minus 1 to the power of a half, we're using the chain rule formula, where you've got a function raised to a power, so the power comes to the front there. You've got the 3x minus 1 in brackets, the function inside. You take away 1 from the power, and then you differentiate what you see inside the brackets. So if you differentiate 3x minus 1, you get 3, you multiply by that. And then back in third form it looks like this. And then we cross multiply here to get the first term, and then we cross multiply this way to get the second term. That's the differentiation done. For simplification purposes, we could combine these into a single fraction. So writing this term as a fraction as well, so everything over 1, and then we can do the where you multiply the denominators together, and then you cross multiply like this to get a single fraction. So we have this result, and then simplifying we have this. Example 4, so differentiating each. So when we differentiate the exponential function, you get e to the power 4x again, and then you have to differentiate the power, which gives you 4, you multiply by that, and we're going to use the chain rule for sine 3x squared. So the power comes to the front, you have your sine 3x, reduce the power by 1, and then you look at what's inside the brackets, the inside function, and we differentiate sine 3x to get 3 cos 3x. And now we can cross multiply and add like this, and if we want we could factorize because we have some common terms to both of these two parts. So there's an e to the 4x, there's a sine 3x here, there's another sine 3x there, that one's squared, so we can take one of the sine 3x's out. That's a multiple of 2, that's a multiple of 2, so we could try something like this and then figure out what goes in the brackets, so we end up with this. For practice, have a go at these questions.